Hello students, and welcome back to another algebra video. You know what to do. Pause the video, try this problem in your notes, and then unpause it to do it with me. Okay, so we want to solve the system of linear equations by elimination, which means that we want to look at our x terms and our y terms. What I notice is that when I look at my x terms, the coefficients are opposites. I have negative x and positive x. So those could easily cancel out if I were to add. When I look at my y terms, they don't have the same coefficient. They don't have opposite coefficients. I have positive y and positive 3y. Not much I can do there. So if I add these equations, I'll see that my x's cancel out. They are eliminated. They go away. Y plus 3y is 4y, and 4 plus 0 is 4. Now, I am going to solve this equation for y. So I need to divide by 4 on both sides, and I'm left with y equals 4 divided by 4 is 1. That's a little cramped down there, so I'm going to write it over here. Y equals 1. Awesome. Now I'm going to use this y that I have found. I'm going to plug it into one of my original equations and solve for x. Remember that it doesn't matter which equation you use when you plug y in. I'm going to use equation number 2 because there are no negatives and I don't want to deal with negatives. So if we take the second equation, I have x plus 3y equals 0, but y is 1, so I'm going to have x plus 3 times 1 equals 0. Which gives me x plus 3 times 1 is 3 equals 0. And I need to subtract 3 on both sides, since the opposite of plus 3 is minus 3. And I'm left with x equals 0 minus 3, is negative 3. Ta-da! So my final answer is negative 3. 1. And I know it says to check your solution. For the sake of space, I don't want to use the space behind my head right here. For the sake of space and time, I'm going to leave checking the solution up to you. So, plug these numbers back in to our original equation and make sure that they work for both of the equations. Okay? That was a nice review from the first part of 5.3 that we did. Now, let's move on to finishing section 5.3. So 5.3, still about elimination. Today, our learning target is that you remember what elimination is. What is it? Why is it called elimination? How do I use it? What are the steps? The success criteria is that you can solve any system of linear equations by elimination. So remember in 5.2 when we talked about substitution, and the first time we did substitution, we had x equals or y equals. And then we added on the part that we didn't have x or y equals, and we could solve any system by substitution. We're doing a similar thing with elimination, where last time, like in the problem in our entry task, the terms were already like the x terms were already the same or already the opposites, so we could just add or subtract the equations immediately, and then we were on our way with step number 2. We didn't have to deal with step number 1. So today we're going to include step number 1 so that we can solve any system of linear equations by elimination. So let's jump right into it with a reminder of what is a system of linear equations. Hopefully by now you're like, Mrs. Dodge, I don't need to hear this every time, but Always good to make sure that we know what we're talking about before we start our lesson. So, a system of linear equations is a set of two or more, except we're not going to do the or more part in this class. A set of two or more linear equations in the same variables. So for us, it's two equations that work together. They're a package deal. Okay, now let's look at these steps again. And this time when we look at the steps, we are going to focus a lot on step number 1. Because step number 1 is what allows us to solve any system of equations by elimination. So multiply if necessary. Yesterday, or in the last video, it was not necessary. In this video, it will be necessary. So we're going to show you when it is necessary, we need to multiply one or both. It depends. We'll see an example of that. Multiply one or both equations by a constant, by a number. So at least one pair of like terms has the same or opposite coefficients. For us, personally, I think it is easiest when we get opposite coefficients because then we can add. Subtracting can sometimes get a little bit confusing. So if you're like me and you don't like confusing things, let's only use opposite coefficients and adding. That's what I'm going to do in this video. If you would like to see the same coefficients with subtracting, we touched on that in the last video, and you can watch that little clip of it again and try some of these problems with the same coefficient and subtracting them. But personally, I think that it's going to be easiest if we do the opposite coefficients and we add them together. Okay, when we do add them together, add or subtract them together, we eliminate one of the variables. That makes it very easy for us to solve that equation for whatever variable didn't get eliminated, x or y. And then we can substitute that into one of the original equations to solve for the variable that did get eliminated in the first place. Okay, let's stop talking and start doing. Let's see an example of this. So, step 1, we're going to see, is it necessary to multiply by a constant or by a number? So let me look at my x terms. I notice that I have negative 10x and negative 5x. So, if I wanted to have the same coefficient, I could multiply this equation by 2. Because 2 times negative 5x gives me negative 10x. And then these would be the same coefficients. But I don't want the same coefficients. We just talked about how I would like to have the opposite coefficients. Which means that this would need to be positive 10x. So let's see. Negative 5 times what will give me positive 10x? Oh, negative 2. So if I multiplied this equation by negative 2, then I could get positive 10x and I would have opposites. Awesome. We can do that. We can totally continue down this path and we will finish the problem with the correct answer. I also want to point out, and I want to get you in the habit, also look at your y terms. Sometimes the x terms, like it's possible, but it's going to get messy. So also look at your y terms and decide which one will be easiest. I could multiply by negative 2, or if I look at my y values, I have positive 3y and minus 6y. So hey, if I multiply the first equation by positive 2, I will get positive 6y. And 6y is the opposite of negative 6y. So if I looked at the y's, I would only need to multiply the top equation by 2. The first one, I need to multiply the bottom equation by -2. So now you decide, which is easiest for you? Do you want to multiply by -2 or do you want to multiply by +2? Personally, I like dealing with positive numbers. So I'm going to choose to look at my y's and to multiply the top equation by 2. Okay, let me rewrite this over here so we have some more space to work with. -10x plus 3y equals +1. So I want to turn this 3y into a 6y, because then that will be the opposite of the -6y. In order to turn this into a 6y, I need to multiply by 2. So what we're going to do, I'll leave that there, is we're going to multiply this entire equation by 2. So the -10 gets a 2. 2 times -10 is -20. -20x. 2 times 3 is 6y. That's what we wanted. And 2 times 1 is 2. Now, I'm going to erase this. I'm going to go back to my original equations. Now, equation number 1 is -20x plus 6y equals 1. This is our new equation number 1. We haven't done anything to equation number 2. This one stays just the way it is. Oh, whoops, I'm sorry. That should be a 2. That should be a 2. Okay. And so we haven't done anything to equation number 2. It is exactly how it was in the beginning. Now, look at that. Plus 6y minus 6y. So now when I add these equations together, my y's are eliminated. And then the problem is exactly like what we did in the entry test, exactly like what we did in the last video. So the most important part of this example is recognizing, what do I need to multiply, like which equation do I need to multiply by what number in order for my x's to be eliminated? You can do the same thing with your y's. What number do I multiply which equation by for my y's to be eliminated? And which one of those things is easiest? If y's are easiest, let's do that. If x's are easiest, let's do that. Okay, and then of course, do it, multiply one of your equations, and then when we rewrite the equations next to each other, things will eliminate. So, let's continue on with the problem. Step 2 is add them together. So -20 plus -5 is -25x. My y's are gone, and 2 plus 23 is 25. If I want to get x by itself, I need to divide by -25 on both sides. Have to do it to both sides. Then I get x equals 25 divided by -25. Oh, that's -1, because it's the same number on the top and the bottom of the fraction. One of them is negative. So there we go. X equals -1. Ha ha ha. All right. Now we can use this number that we have gotten for x. We can plug it in to one of our original equations. Now, both of the original equations have negatives in them. Sad. But which one's going to be the easiest? Let's see. Maybe equation number 1, since it has the fewest negatives. So let's do that. I have -10x plus 3y equals 1. And I'm going to replace x with -1. plus 3y equals 1. Negative 10 times negative 1 is positive 10. Plus 3y equals 1. Let's see, then I'll subtract 10 from both sides. And I'm gonna come over here now. 3y equals 1 minus 10 is, 10 minus 1 is 9, and the 10 is negative, so 9 is negative. 1 minus 10 is negative 9. Okay, and now to get y by itself, since I have 3 times y, I need to divide by 3 on both sides, and I get y is equal to negative 3. Negative 9 divided by 3 is a negative 3. So there we go. I have x, I have y. All that is left is to write it in the form x, comma, y. Final answer. Ta-da! Okay, we can check and make sure that we were correct. Multiply. So they multiplied the bottom equation by negative 2. Doesn't matter. We multiplied the first equation by positive 2. But let's see if they get the same answer as us. Y equals negative 3, and x equals negative 1. So the solution is negative 1, negative 3. And oh my goodness, that's what we got as well. So booyah! We are correct. How exciting. Okay, let's try one on our own, shall we? So, what I would like you to do at this point in time is pause the video and try this problem by yourself. It doesn't matter if you get stuck. It doesn't matter if you can't completely finish the problem. Learning is about making mistakes and trying and struggling. That's all a part of learning. So, if you try and you can't quite finish it, that's okay. That's part of learning, and you can come back and watch me do it, and we can do it together. So, let's take a look at our x terms. I have positive x and positive 4x. So, I would need to multiply the first equation by negative 4. All right, so I had negative 4x and positive 4x if I wanted to look at my x's. Now, if I wanted to look at my y's, I have positive 4y and positive y. Oh, so I'd need to multiply the bottom equation by negative 4. Either way, I'm multiplying by negative 4. So it doesn't matter which one we do. We did y last time. Let's do x this time. So I'm going to take equation number 1, x plus 4y. Let me rewrite that. X plus 4y equals 22. And I want my x to be negative 4x in the end. That way, it's the opposite of positive 4x. So we are going to multiply this entire equation by negative 4. And negative 4 times x is negative 4x. Negative 4 times 4y is negative 16y. And negative 4 times 22, see, negative 4 times 2 is 8. So negative 4 times 22 should be 88. I could double check with my calculator. Yes. Negative 88. Good thing I checked with my calculator. Even teachers make mistakes. Okay, perfect. Now I have a new equation number 1 where the x term is going to be the opposite of 4x. So now, let's rewrite our equations next to each other. So my first equation is negative 4x minus 16y equals negative 88. And equation number 2 hasn't changed. We haven't touched equation number 2. So we have 4x plus y equals 13. Now, that was the hardest part. In my opinion, I should say in my opinion, that's the hardest part of the problem. Because now, we know this. We did this yesterday. The negative 4x and the positive 4x cancel when I add the equations together. So negative 4x, positive 4x is gone. I am left with negative 16y plus y. So I'm 1 less negative than negative 16, which would be negative 15y, equals, negative 88 plus 13 is negative 75. Okay. And then, if I want to get rid of the negative 15, I want y by itself, I need to divide both sides by negative 15, and I get that y is equal to positive 5. Awesome. Am I done? Finished? Can move on? No, remember, I need to find x still. So I need to take what I have for y, and I need to plug it in to one of my original equations. Now, everything's positive. Which equation will be easier to do? Well, I want to solve for x in the end, right? I have y, I want x. So, notice that in equation number 1, x doesn't have a coefficient, or its coefficient is 1. So I wouldn't have to divide by anything. So let's plug it into equation number 1. We have x plus 4y equals 22. And we know that y is 5. So x plus 4 times 5 equals 22. Gives us x plus 4 times 5 is 20 equals 22. And if I want x by itself, I need to subtract 20 on both sides, and I get that x is equal to 22 minus 20, is 2. Yay! Okay, so we have x and we have y, which means that my final answer is x, comma, y, or 2, 5. Ta-da! All right. Now, the last thing I would like to do in this video is we're going to do a little summary of Chapter 5 so far, because in 5.1, we learned about graphing, how to solve by graphing. In 5.2, we learned how to solve by substitution. In 5.3, we learned about elimination. Specifically today, we learned about elimination when we had to multiply first. So this little summary box tells you when would you want to use each of these things. Like, if they all do the same thing, right? They all solve systems of linear equations. They all do the same thing. Why do I need to learn how to do it 3 different ways? Because some of them are more helpful in different situations. So for example, to graph, like when would you want to use graphing? Well, if you want to estimate solutions, if you want a quick, graph, looks like it's right there, estimating solutions would be a good time to use the graphing method. If one of the variables in one of the equations has a coefficient of 1 or negative 1, it's going to be pretty quick and easy to solve one of them for x or y. And then, boom, I can go right into substitution. So if I can go straight into, if step 1 of substitution is rather easy, we use substitution. Now, elimination, If at least one pair of like terms has the same or opposite coefficients, I'm already ready to cancel it out. I'm so ready to just cancel it out. That's what we did in the last video. So if you have that situation, elimination is just sitting right there begging you to do it. And elimination multiply first is when, basically when all else fails, kind of. Like when substitution looks like it's gonna be gross, when graphing looks like, you know, I'd have to solve, I have to put it in y equals mx plus b, and that looks like a lot of work. Then what we learned today in this video is going to be your best bet. So if there's only one way that you learn how to do, I recommend that it be elimination, because sometimes it can be the easiest. Okay, so I would recommend putting this in your notes as a little bit of a guide as to when to use each of the methods that we've learned in Chapter 5 so far. And you know what time it is? It's time to assess your understanding. So, our learning target and success criteria were that you remember what elimination is, and then you can solve any system of linear equations using elimination. So, where are you at on that? Are you horribly lost? Are you getting there, or are you completely solid on your understanding? Where are you? Rate yourself and then take the appropriate action. So if you're a 1, ask questions. That's probably the first step that you need to do. If you're a 2, you can get started on the homework and see if, as you're working on the homework, if you have questions. And if you're a step 3, or excuse me, if you're a number 3, you can help other people. You can help your friends, you can teach your parents about what you're doing, you can take it a step further, whatever you'd like. Here are some practice problems. That should not say classwork, I apologize. That should say practice problems. Although these are the problems that I would assign if I were assigning you homework, but that's not what I'm doing in this video. So these are practice problems that you could do to practice the skills that you have learned in this video. And of course, we're going to end our video with a launch. Today's launch comes from Tom Peters, and he says, celebrate what you want to see more of. I mentioned this in one of the launches in a previous video, was what you look for is what you're going to find. If you look for all the negativity in the world, you're going to find negativity. If you look for all the positive things in the world, you're going to find positive things in the world. And in like the people around you, if you look for negative things about that person, if you're looking for a reason to hate that person, you're going to find it. But if you look for a reason to love that person, you're also going to find it. Every single person, I try to find something nice to say about every single person, because it's possible. It's totally possible to find something nice to say about every single person. Everybody has good qualities about them, even if you might not like them, or even if they do something bad or bad things. So celebrate what you want to see more of. If you want to see more kindness, celebrate kindness. Point it out when your friends are kind. That was really nice. That was awesome. If you want to see more patience, celebrate patience. Wow, I did a great job of being patient today. Hey, thank you so much for waiting for me. Thank you for being patient with me. Whatever it is that you want to see more of, if it's more laughter, more smiles, more happiness, more togetherness, celebrate that. And make sure that the people around you know that you really appreciate that and that you love that. Because the more we know what we like, what we enjoy, what we want to celebrate, then we have a goal that we can work towards. So celebrate what you want to see more of. That is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.